Hello and welcome. Ever thought about the mathematics behind everyday objects? Let's take a journey together. When we think of math, numbers, equations and graphs might come to mind. But what if I told you that mathematics is not just about numbers and complex equations? It's much more than that. It's about patterns, structures and ideas. It's about seeing the world in a new light, discovering connections where none seem to exist, and finding beauty in the most unexpected places. From the coins in your pocket, to the manhole covers on your street, and even to the wheels of your bicycle, mathematics is seamlessly woven into the fabric of our daily lives. It's hidden in plain sight, silently shaping the world around us. Today, we'll explore the math behind manhole covers, coins and bicycle wheels. Intrigued? You should be. Let's embark on this journey of discovery together and see where the magic of mathematics can take us. Have you ever wondered why most manhole covers are round? It's not just for aesthetics, there's a mathematical principle at work here. It's all about something called constant width. Now, what does that mean? Well, it's a property that some shapes have where their width remains the same, no matter how you rotate them. Let's take a circle, for instance. No matter how you spin it, the distance from one side to the other, or its diameter, stays the same. This is a handy feature when you're dealing with a manhole cover. Why? Well, imagine if the cover was square. With just a little tilt, it could fall right through the hole. But a circle? It's going to stay put no matter what. Now, you might be thinking, surely the circle can't be the only shape with constant width. And you'd be right. In fact, there's a whole class of shapes that share this property. They're called Reuleaux polygons, and they all have this constant width characteristic. So why aren't we using these other shapes for manhole covers? Well, the circle has some other advantages. It's easy to manufacture, for one, and it can be easily moved by rolling, which is a big plus when you're dealing with something as heavy as a manhole cover. But the key point here is that the shape of the manhole cover isn't random. It's not just about what looks good or what's easy to make. It's about applying mathematical principles to solve real-world problems. And that's what makes mathematics so fascinating. It's not just about numbers and equations. It's about patterns, shapes, and how they interact with the world around us. So, the circle isn't the only shape with constant width. Intriguing, isn't it? The world of mathematics is full of surprises, and it's all around us, even in the most mundane places like the manhole covers on our streets. Who knew math could be so down to earth? Let's consider coins. Ever noticed the unique shape of the 50p English coin? Unlike most coins we encounter in our daily lives, the 50p English coin isn't perfectly circular. Yet it possesses an intriguing mathematical property. Despite its seven-sided form, it maintains a constant width, much like a circle. Isn't that fascinating? The concept might sound complicated, but it's rather straightforward. Picture a typical coin. When you rotate it, regardless of the angle, the distance across its center remains consistent. This is what we mean by a constant width. Now, the 50p coin, despite its heptagonal or seven-sided shape, shares this exact characteristic. Rotate it however you wish, and the width remains the same. But why, you might ask, would someone design a coin like this? Well, the answer lies in practicality. When you insert a coin into a vending machine, a slot measures its width to determine its value. If the coin's width varied, it could get stuck or, even worse, be misidentified. With a constant width, despite its orientation, the coin smoothly passes through, ensuring a hassle-free transaction. In fact, the unique design of the 50p coin was a result of a deliberate effort to create a shape that could easily be distinguished by touch, sight and vending machines, all while maintaining a constant diameter. It's a brilliant example of how mathematical principles can be applied to solve real-world problems. By creating a non-circular coin with a constant width, the designers of the 50p coin achieved something remarkable. They were able to break away from the norm, introduce a new shape, and still retain the functionality of a circular coin. They found a solution where one didn't seem to exist. In a sense, they reinvented the wheel, so the inventor of the 50p coin essentially reinvented the wheel. The next time you come across a 50p coin, take a moment to appreciate the genius behind its design. It's not just a piece of metal. It's a testament to the beautiful synergy of mathematics and practicality. Now, let's take a look at bicycle wheels. As we continue our journey through the fascinating world of constant width shapes, we come to an object that exemplifies this concept in motion, quite literally. You see, the bicycle wheel is a perfect representation of a shape of constant width in action. When a cyclist pedals, the wheel's rotation is transferred into linear motion, propelling the bicycle forward. This is a beautiful example of how a round object's constant width allows for smooth and efficient movement. But what would happen if we replaced the round wheel with a shape that does not have constant width? Imagine a bicycle with triangular wheels. As the triangle rotates, the bicycle would move up and down with each turn of the wheel, resulting in a very bumpy and inefficient ride. Now, what if we used a shape of constant width that isn't a circle? Let's say we used the shape of the 50p coin. As the coin shape rotates, its constant width would mean that the bicycle stays at a constant height, just like with a circular wheel. The ride would be just as smooth and the wheel would still transfer rotational motion into linear motion efficiently. This is an example of reinventing the wheel in a literal sense. But it's more than just an entertaining thought experiment. In fact, some bicycles with non-circular yet constant width wheels have been built and ridden. It's a testament to the power of mathematics and its ability to provide surprising and innovative solutions. This brings us to a profound realization. The shape of the wheel, whether on a bicycle, a car, or even a skateboard, isn't merely a matter of tradition or aesthetics. It's a product of mathematical principles that ensure efficiency and functionality. The beauty of mathematics lies not just in abstract equations, but in the practical, tangible ways it shapes the world around us. So the mathematics of constant width shapes is crucial even when we're cycling. What's the common thread among all these objects? Simply put, it's the mathematical concept of constant width. This concept, though it may sound abstract, is deeply woven into the fabric of everyday life, from the manhole covers we walk over, to the coins jingling in our pockets, to the bicycle wheels that keep us moving forward. Let's recap, shall we? A shape of constant width, like a circle, has the same measurement across, no matter how you orient it. But circles aren't the only shapes with constant width. There are other, more complex shapes that share this property, like the seven-sided 50p coin. Despite its irregular shape, the 50p coin maintains the same width no matter how you turn it. This same principle is applied to manhole covers. A round manhole cover, thanks to its constant width, won't fall into a manhole regardless of its orientation. This makes it a practical and safe choice. But it's not just about safety. The mathematical properties of these shapes have practical applications in engineering and design, making our everyday life more efficient and convenient. Now let's talk about bicycle wheels. They're circular, right? But what if they weren't? What if they were another shape with constant width? Would they still function the same way? The answer is, surprisingly, yes. In fact, there are bicycles with non-circular wheels that roll just as smoothly as their circular counterparts. So we see that the concept of constant width is a common thread that ties together seemingly disparate objects like manhole covers, coins, and bicycle wheels. Mathematics, in its beautiful and abstract glory, underpins the design and function of these everyday objects, ensuring they serve their purpose efficiently and reliably. So the next time you see a manhole cover, a coin, or a bicycle wheel, remember they're more than just objects. They're mathematical marvels in disguise. Mathematics is indeed everywhere, even in places we least expect. From the manhole covers we casually walk over, to the coins we use daily, right up to the wheels that keep our bicycles moving, mathematics plays an integral role. It's not just about numbers or equations, but about patterns, shapes, and ideas that influence our everyday lives. The concept of constant width, a seemingly simple idea, underpins the design of many items we take for granted. It's a testament to the power and ubiquity of mathematics, a language that helps us make sense of the world in unexpected yet profoundly practical ways. So, as we close this chapter, remember that mathematics isn't confined to textbooks or classrooms. It's a living, breathing entity that's constantly at work, shaping our world in ways we might not always see. Next time you come across these objects, remember you're looking at mathematics in action. Until next time, keep discovering the math around you.